All right, so there'd be a second example. So if I've got a different force, now I hope I did this right. Pretty sure I did this right. I've got an applied force of 30 now. The last time we calculated with the same coefficient of static friction and kinetic friction, we had this graph, and this was basically the force of friction static max, right, was 25 newtons. So if we apply something greater than 25 newtons, we'll not only get it going, but this tells me there's a constant friction force when it's moving. It's not changing. Once you get it moving, the friction force doesn't increase or decrease. It stays the same. So force of friction, we should be in the kinetic zone now. But let's just check, okay? We got to do our free body diagram. I'm hoping when you guys take the assessment, you'll include those. Force of gravity equals 50 newtons. There is no upward influence or downward influence. You could push down on this box too. It's horizontal, so force normal is going to equal force of gravity, and that is going to be 50 newtons also. So now what is our force of friction? And I'm going to say it's kinetic, but let's check. So force friction static is going to be 50 times 0.5 equals 25 newtons. Since we've exceeded it, we are now force friction kinetic. Now the weird part is I've applied 30 newtons, okay? It's greater than my static friction force. So now that it's moving, it takes less force to keep it moving. To get it moving, I need more force to get it moving than I do to keep it moving. So again, 50 times 0.3 is 15 newtons, right? So this is 15 newtons, and we're applying 30, so the kinetic friction is 15 newtons, okay? Now, if you are reading me, right, now I can calculate what my acceleration is, right? But that's an aside. All I'm asking you to do is calculate friction force, and let's see, I do have a little room. What is my acceleration? From my free body diagram, I'd have 30 minus 15 equals 5 times my acceleration, the mass of the object. So 15 equals 5 times a, so acceleration equals 3 meters per second squared. So once I can calculate my friction, I can either determine, like example 1, I didn't have enough force to overcome static friction, so the acceleration was 0, velocity was 0. But in this case, I can overcome static friction. I'm overcoming that max. Therefore, I've got movement, and I have an acceleration of 3 meters per second squared. So that's example 2. 1, first example, not moving, haven't overcome static. And 2, you've overcome static friction, and therefore you're in the kinetic zone, a nice constant, once it's moving, 15 newtons. And that's because it's related to 50 times 0.3, right? I should have had that. That's 50 newtons, right, times the coefficient of 0.3 gives you 15. Okay? I hope that helps. You've seen the conceptual of how to calculate it, and now as far as relationship between force normal and force friction, and now these are the examples on how to actually calculate your force of friction and ultimately calculate your acceleration. I think that's it.